Good morning, students. So today we are going to study about esterification of carboxylic acids. We already know what are carboxylic acids. They have a functional group C double bond OH, right? They have a functional group this. They are carboxylic acids and they are acidic in nature, right? And for the esterification process, we need two compounds. First, we need carboxylic acids, and another one we need alcohol, which has a functional group OH. Okay. Now they both react and gives us a compound which is known as ester, which has a functional group R C double bond O O R dash. This is the functional group of ester. Esters, we already know they are compounds which are formed when carboxylic acids react with alcohols to form esters. Esters are the compounds which has a fruity smell. Okay, they have a very pleasant and fruity smell, and this reaction occurs in the presence of a catalyst, that is H plus. Okay, we can write a reaction for the esterification. The reaction will be R C double bond O OH. It reacts with alcohol, that is R dash OH, in the presence of H plus. As I said, H plus here is used as a catalyst. So we are using in this reaction for the esterification process, we need acid as a catalyst. So what type of acids we can use here? We can use mineral acids such as concentrated H2SO4, or we can also use HCl gas, right, which can give us a proton, that is H plus, and this will lead to the formation of ester, that is your RC double bond O R dash. This is your ester forming a side product, that is water molecule. Okay. Now, as I said, this is going to be a carboxylic acid, alcohol and ester plus water is going to be the product. So here your R and R dash can be R and R dash can be your methyl group. They can be your ethyl group, or they can be your phenyl groups as well. Okay, etc. They can be ethyl, phenyl, methyl, etc. Now let's study about the mechanism of the esterification procedure. So first of all, what is the reaction happening? Carboxylic acid reacting with alcohol in the presence of acid, which is used as a catalyst, gives you the product, that is ester plus water. Let's see the mechanism. Okay. Now, in the mechanism, first of all, before we proceed to the mechanism, first of all, we need to know what kind of reaction is esterification. Esterification is a nucleophilic acyl substitution. It is nucleophilic acyl substitution. What is the meaning of nucleophilic acyl substitution? Nucleophilic acid substitution means a nucleophile is going to attack on the carbonyl carbon. That means, just for a simplicity, for an example, I'm writing that a nucleophile is going to attack on the carbonyl carbon and gives you an addition product. That means you're going to get OH and a nucleophile. Okay, it's just for basic understanding. Okay, the whole reaction I'll be explaining to you just now. So it's a nucleophilic acyl substitution. Now let's proceed to the mechanism, where things will become more clear to you. Okay, in mechanism, what will happen? First of all, our acid, that is R C double bond O OH, gets protonated. Okay. This lone pair of oxygen goes and attacks, as we already know that oxygen has two lone pairs, right? So this lone pair, one of the lone pair of oxygen is going to attack on the H plus and is going to get protonated. Now, first of all, why do we need to protonate this? Why it does get protonated? We already know the acid-base reactions are the fastest reactions. But the main reason over here is protonating is that when we do the protonation of the oxygen, we get this. We get RC double bond O H with a positive charge on oxygen and OH. We get this, right? Now, this protonation of oxygen facilitates the nucleophilic addition of alcohol, right? Nucleophile R dash OH, okay? Now, here our alcohol is acting as a nucleophile. It's acting as a nucleophile, okay? We already know that oxygen again has 2 lone pairs with itself, right? Since it is acting as an nucleophile, its lone pairs, oxygen, what does oxygen do? Just a minute. Okay. Yeah, it has a lone pair. Now what does this lone pair do? Since this protonation is helping alcohol to attack on the carbonyl carbon very easily, what happens is this lone pair goes and attacks on this carbonyl carbon, and this bond gets transferred to the oxygen, alright? And we are going to get our COH OR dash H with a positive charge and also OH. Okay, this is a tetrahedral intermediate. This is our intermediate which has a tetrahedral shape. So it is tetrahedral intermediate. Okay, so it's a tetrahedral intermediate. Now next step is the proton transfer. Proton transfer occurs from this oxygen to this oxygen. This proton is going to get transferred to this oxygen. Now next step is what? Proton transfer from the tetrahedral intermediate, proton transfer. Okay, what will happen? As I said earlier, that again it has a lone pair. It goes and attack on this proton H, and this gets here, and we will get our COH O R dash with your OH2. Now, as you can, we already know that OH2 plus this is a better leaving group, because when it leaves as a neutral water molecule, right? So here this is going to leave, and what is going to happen? And since it leaves. Now when this OH2 is going to leave, there is going to, a plus charge is going to be generated on this carbon. So what will happen? This oxygen gives its lone pairs to this oxygen. This oxygen gives its lone pairs to the carbon, and what we will get? We get water molecule is eliminated from the reaction, and we will get our C double bond OH, plus charge is going to be here, and here OR dash. So this is nothing but our protonated ester. We already got our ester, but this is our protonated ester. As I said earlier in the reaction, that we added this H plus in the first reaction, we added H plus as a catalyst. Now, as you already know, what is a catalyst? When we add a catalyst, it has to come out of the reaction as it is, right? It helps in, what is a catalyst? Catalyst helps in forming the product, in the formation of product, and it leaves the product as it is. Like as you added the catalyst, it's going to come out as it is. Okay, so this H plus has to leave. Since oxygen has a plus charge on it, and it is, of course, oxygen is a very electronegative atom and is not stable at all with the plus charge. So what it has to do, it has to leave, it has to remove this H plus from itself. So when this H plus gets removed, when this H plus is removed, H plus will be eliminated here, minus H plus, and what we will get? We will get our C double bond O and OR dash. So this is the ester that we need. Okay, again I'll summarize you the whole mechanism. What is happening over here is that, first of all, we are taking a carboxylic acid, our COH. Okay, R can be anything, ethyl, methyl, or benzyl, even phenyl. Okay, now first, since we add an acid as a catalyst over here, it can be concentrated H2SO4 or HCl gas. Okay, it will form a protonated compound, protonated acid is going to get formed. That is RC double bond O, OH plus and OH. Okay. Again, this OH is not stable. Okay, with the O is not stable with the plus charge on it. And here our alcohol is working. Alcohol is functioning as a nucleophile. As I said earlier, that this esterification procedure is a nucleophilic acyl substitution. This protonated protonated oxygen is going to facilitate the attack of nucleophile, that is alcohol, on this carbonyl group. Okay, since it's a nucleophile, it attacks on this carbonyl group. This gets transferred, and you will get a tetrahedral. You will get a tetrahedral intermediate in the product. You will get a tetrahedral intermediate, that is, you're going to have two oxygens, two hydroxyl groups on the carbon, and OR dash as another group. Okay. Now, first of all, before proceeding it, we already know that a carbon having three oxygens is not stable again, right? So it has to remove something from it. So first of all, what happens from this tetrahedral intermediate is that proton transfer is going to happen. This proton is going to get transferred to this hydroxyl group and is going to form an OH2 plus group, which is a very good leaving group, because when it leaves, it becomes a neutral water molecule. And when it is going to leave, since a carbon is going to get a plus charge on it, the plus charge is going to get generated on the carbon. This oxygen is going to transfer the lone pair and is going to form a protonated ester, RC double bond OH with the positive charge and OR dash. A protonated ester is going to form. Now what will happen next? What happens next is that H plus is going to leave, because again oxygen has a plus charge, not stable. So H plus is going to leave. H plus is eliminated from the protonated ester, and we are going to get our ester, which has a fruity smell, which has a very pleasant and fruity smell. So this is all about the mechanism of esterification of carboxylic acids. I hope you all understood this video, and thank you so much.